Okay, our Hangout is now live on air. So let me go ahead and take a look at our little showcase and questions on the left here. Features disabled. What? Well, I guess I'll figure that out. All right. Welcome everybody to the second Akka.net virtual meetup. And today we're going to have a couple of talks. One from Chris Martin from EventDay is going to talk about his Akka.net DSL. And Chris Stevens is going to talk about his cluster monitoring tool. And so we're going to go ahead and have the two of them present and talk a little bit about their use cases. If this is your first time participating in a virtual meetup, welcome. We have the little QA tool that's built into Google Hangouts here. So if any of you have a question for me or for Roger or for any of our presenters while they're demonstrating today, you can go ahead and ask a question there. And I believe you have the ability to vote on them too while things are going. So please take use of that. We definitely want to answer your questions. And so just to give you a little bit of structure for how we're going to do this, I'm going to talk a little bit about some announcements around the Akka.net community in general. Then we're going to get into our presentations. So each one of our speakers is going to maybe show you a little PowerPoint and then do a demo of their project. And then we'll take some time for questions for each. And then at the very end, for people who want to stick around and ask some general questions, Roger and I and the two Chris's will both field any questions you have that maybe you didn't get answered earlier or maybe weren't related to the material we're directly showing. But that's what we're going to do. And so the first couple of announcements that I wanted to go through real quickly is number one, we released Akka.net 1.06 last week. And so that release was about, I guess, 6 weeks from 1.05, but we made some massive improvements between the two. The biggest improvement that we made was to the performance and general reliability of Akka.remote. We discovered around the time Akka.net 1.03 or 1.04 shipped that the performance of Akka.remote had degraded pretty significantly. And we used NBench and some to go ahead and start measuring how what the throughput of our sort of remoting pipeline was. Made a whole bunch of changes to it, and I think we improved the overall throughput by about 8x of what it used to be before. And we also changed some other things around like the way quarantining and gating works. So people have been very happy with that. We also made a number of significant fixes to Akka.persistence, fixed a number of race conditions and bugs and all sorts of other issues there. And so Akka.persistence is looking much better in this patch too. And then the last really big thing we did was Bartosz, one of our longtime sort of core contributors, released alphas of two modules he's been working on, Akka.Cluster.tools and Akka.Cluster.sharding. And so these are in sort of an alpha state right now. And just to give you a real high-level overview of what these two modules do, Cluster Tools introduces a few new components. For example, Cluster Tools introduces this concept called a cluster singleton. So if you need to have exactly one instance of an actor running around your cluster, and the node that actor is on dies, exactly one instance of that actor will be recreated on a new node. So that's a cluster singleton. There's also distributed pub sub built into there, which is a way of doing event subscriptions and publications transparently across the cluster. And then there's a cluster client, which is a way of being able to subscribe the changes in a cluster without actually participating in a cluster. So it's kind of like the difference between writing a database server that's actually acting as a database versus writing a driver for a database. So cluster client's effectively a driver for your Akka.net cluster. And then cluster sharding gives you the ability to partition and shard and then shard data in real time in multiple different nodes on your cluster. And if one shard replica goes down, another one will be recreated somewhere else. So those two modules are very new, and we're already starting to get some people using them. In fact, I think Chris Martin already submitted a pull request for changing some stuff inside cluster sharding. So those are available now. So that's Akka.net 1.06. We recommend that everybody upgrade if you haven't already, and start giving us some feedback and comments in Gitter chat about how how it's been working for you. The next thing I wanted to talk about, real briefly, as far as announcements go, before we get started, I'm going to share my screen here real quick. Is Anthony Brown, one of our longtime Akka.net community members, has been working over the course of the past year on writing an Akka.net book for Manning publications. And so it's called Reactive Applications with Akka.net. It's in the Manning Early Access program now, which means sort of pre-order the book and you get the first few chapters that have been published. And so far, we've been getting a lot of enthusiasm from the community. And I really wanted to put this out in front of all of you to say that if you're interested, you should go ahead and buy a copy of the Meet here and let Anthony know what you think. So I'm going to go ahead and paste this into our little showcase area in a little bit. And that link will be available for you inside the Hangout. So that's the gist of our announcements for the time being. And like I said, if any of you have any questions, go ahead and please use the feature on Google Hangouts to let us know. And if there aren't any other major announcements that we need to cover right now, I'm going to go ahead and turn the microphone over to Chris Martin. Chris, are you ready to go?
I sure am.
All right, take it away.
All right, well, I'll just jump right into the slideshow, I guess. So here's our DSL. We all know that Akka is pretty awesome. Obviously, we've been using it for quite a while now. But there's always some limitations with these kind of systems, and it's mostly with developing, right? Like writing all these messages over there, it's a pain in the balls. It's boring, it's repetitive, it's slow. And so we created a DSL that will generate most of this stuff for you. And the basics of it will generate immutable messages. So the top thing is a DSL file. Hit save, we'll generate some code for you.
Hey Chris, we can only see your Visual Studio sample at the moment right now.
Click over to my other thing here. I have another screen there.
All right, got it.
Got it? Let me start over. Oops.
Open source production values, guys. It's all good.
Yes. All right. We all love Akka, but some issues, right? And it's not Akka itself. It's the programming environment. It's the architecture. Writing all these messages is just boring. So we came up with the DSL, create a simple little text file, and we'll generate some code. Mutable messages by default, we'll generate that code. You can declare optional parameters, so you don't need to give them to at construction time, and that will create with the default values of that parameter. We'll generate a toString method for you if you care to. We can generate enums as well. Marker interfaces are pretty handy if you want to subscribe to certain messages without knowing exactly what they are, or just do it generically. So we can do that. Mark it with the interface. We support namespacing, so you can import and you can enclose. So that will generate that. You can reuse your parameters. So if you have multiple messages here, you don't have to keep typing GUID, user ID, or stuff like that. We also generate some helpers for in your actors. A lot of people like to use receive actors, and we'll generate this little state subscription class that you can override or implement and have all your message matching done for you automatically. And then you can implement these when methods. So it's kind of a strongly typed thing at that point. Let's see. We can also generate an interface for these state subscriptions. So if you have different implementations of these guys, you just have to you can program against the interface. Some tiny little DDR or DDD helpers that, in hindsight, aren't that helpful anymore, but they're there, and I use them all the time. That will create those, and then that's the basics of the DSL. And if we switch back over to the Visual Studio tab there, Aaron.
Got you covered.
Let's see here. So you can create this little. This is also a Visual Studio plugin, by the way. So we have support for Control S. You save the file, we'll generate the code. Here's a whole file here, a whole DSL file. We got our namespace, our parameters here, marker interface, and these are our messages that we're creating. So we're building a little analytics kind of server thing, and we're going to record some clicks and some views, and every once in a while we're going to generate the stats for our database to index. And this is a guy that will just go. It'll be passed into the stats generated message, which will implement this marker interface that we have another indexer over here that can subscribe to this. So we generate that code, and it turns out just like you would expect. There's the marker interface. All our messages are generated for us. We also generate this handy little method called setProperties, which I'm not sure the naming is totally correct, but that allows you to safely change these classes in an immutable way. So we'll return a new instance of the class with your properties changed for you. It's pretty handy. Here's a good example of that. So if you just want to change the clicks of this guy, you'd say .setProperties and give it a new clicks value, and we'll do the work for you and give you a new immutable message. So that's all the messages generated, and a little use of it is, it's just an actor. It's what you guys are used to already.
Yeah, so just so I understand correctly, so this actor accumulates all those messages that you defined in your DSL and reports on like the aggregate of how many of those it received over some window of time, right?
So this example, this example is going to receive, a clicked and a viewed, and we're just going to store those until a configured amount of time. We'll repeatedly tell the indexer over here that, hey, we generated something, so we're not pounding the database, right?
Mm-hmm.
Not that that's a big deal. This is just an example. So the indexer here, this DSL is a little different. We can define our state subscription, right? And then we have an entity, which is a mutable class. I'm not sure that's going to survive in this project for very long, but it's there. Then our messages, save, roll up, and get latest stats is more of a query for this actor. And when we tell the state, we're going to generate those receivers for the state. And you can implement that state subscription here. And again, this store here, this is an interface that was generated via this. And a good use case for that is in these indexers, and anything that has an underlying data store, you're usually going to want a couple of implementations, one for development, one for production. And my goal was to make it really, really easy to implement those and not forget stuff, right? You got 50 methods that you support on an actor, and going to create a new implementation that is dangerous at best, right? Because you're going to forget stuff. You don't have nothing to program against. There's no interface usually. So what you can do is now implement this store interface, and we're going to get all our whens that we care about, and you'll have to implement them. Does that make sense?
That's really cool. So just so I understand correctly, so this is a receive actor under the hood, right?
This in particular isn't just a actor base that implements this interface. So you get these guys, and then you'll need a little bit of glue, and I'm going to call that over here the store subscription, which just takes an implementation of the store and kind of forwards it through.
Got it. Can we see the receive method on that actor?
On the indexer itself?
Yeah.
So this is a receive actor. This is not generated automatically.
Mm-hmm.
It's kind of like your top level guy, and you receive what you're interested in, and then you can get down into the generated code.
Got it. Okay.
So far, this has been very, very time-saving for me. You're writing a big system, you have thousands, not thousands, but we have hundreds of messages, and writing those by hand becomes very hard and very boring and repetitive.
Why don't you tell us a little bit about what EventDay does and what you're using Akka.net for, and how this helps?
Okay, so EventDay is an event management platform. Event, like as in conferences, for event organizers. We do a lot of integrations with tons of different CRM systems. We do a lot of emailing on behalf and email reporting and SMS reporting and all sorts of stuff for event managers and organizers. And this just helps us. Akka helps us immensely. First of all, it's our before we started using Akka, we rolled most of this stuff by hand, and very error prone, lots of moving parts, very hard to manage. Akka.net has helped us immensely in that area. We don't have to think about the hard parts. It just kind of works, and the idea of having clustering available for us out of the box is just great. And so far so good. We should be launching in the next month or two with our new version with Akka, and it's awesome, man.
Great. And what makes a lot of sense to me, given what you said about your business, is that you have a whole bunch of inbound data from all the things that are happening at an event, right?
Mm-hmm.
People scanning badges, people registering, and all sorts of different little flows that are happening there. And you've got to produce messages going back out to them too, like sending someone a text, letting them know that a session's starting or something like that.
That's right. That's actually a use case.
Yeah. And so you've got a system that's already inherently event driven, just by the nature of what your real world customers have to do.
That's right.
And being able to go and synthesize all the boilerplate code for representing that from a DSL like this is a huge time saver for you every time you need to make a change to that domain, right?
Exactly. It's a time saver for sure. Yeah, and it makes development very fast as well, right? You can go change the message in a second. With a button click, you got a new signature.
I've got a question on the DSL. How's the error handling if someone writes some sort of syntactic error in the DSL?
That's a good question. So these are let's see. Here's a good example. Say we messed that up, right? We got a parameter called URI. Can you guys all see this?
Yeah.
Text big enough? Okay. So we got a parameter here called URI. And we misspelled it here. As soon as you press save, our output here, you can see, maybe you can see, I don't know if I can make that bigger, but I'll just paste it in here. It doesn't matter. I'll delete it. So you can see here, try to use undefined property URIs. We kind of safe boat you there, and it won't generate the code, right? Like you'll start throwing all these errors. So we can easily fix that, and we will be back to golden here. That's one use case where I can catch that stuff. It could obviously be better, but if you do mess up, see, and put like a I don't know. I can't catch all errors. This is a quick project that was built for us internally. I would like it to go out to the public, but I catch some stuff. I guess the answer to your question is if you mess up in the file, you're not going to get any code, and you will get an output in this little pane here.
So just for the sake of clarification, because I wasn't sure if you explicitly said this earlier, the way the DSL compiler works is you have a Visual Studio extension that you install, right?
That's correct, and I'll post a link to the GitHub project. All you got to do is compile it, and you're given a VSIX. Double-click that, it'll be installed in Visual Studio.
So I went ahead and I selected Scott's link to the EventDay DSL, so that's currently marked as the question that's being answered for anyone who wants to get access to this. And then I also went ahead and added on the Google Hangouts page itself. I posted a public link to it too. So
great.
So if you all are curious and want to use this yourselves, the links are right there, and we'll paste it again in the Gitter chat too. Okay, and so now what I'm going to go ahead and do here is open up the floor to questions from the audience. So I'm going to go ahead and pick this one from David Horster. So his question is, for the DSL, can you generate read-only fields for messages? Is there a template that can be updated?
They are read-only by default, so all these messages are generated immutable. If that answers your question, we do generate a getter, a public getter, and a private setter.
Okay, got it. And so I'm going to go ahead and select a... so I'm not sure what Bart's question is here, but I'll go ahead and bring it up anyway. He said at one point, I'd suggest with properties. Yeah, I'm not sure what he's referring to there.
It's about the set properties method name.
Oh, yeah. Okay, I like that. Like I said, I wasn't a big fan of the method name, but sometimes you just got to go with what you came up with.
There's only two hard problems in computer science: cache invalidation and naming things.
That's right.
Yep. All right. Thanks, Bart. Next question from Ibrahim Haddad. Is there documentation for the DSL? So I'm assuming he means for the syntax itself.
Very little. That's something I'd like to work on. Unfortunately, we all have full-time jobs as well. But it is an open source project, and I would love some help.
All right. That sounds good. And then next question is from Philip Loriano. So there's no partial class generation?
I don't see a need for partial class generation. There's a couple problems with that, with partial classes, and one is I don't believe they're cross-assembly, so that could be a problem in some systems. I'm perfectly fine with having to implement an implementation of an abstract class that we generate. I assume we're talking about state subscriptions. I'm perfectly happy just saying, hey, I got a new one of these guys, implement this.
Yeah, I think this can boil down to things like, let's say you want to generate some special equality operator. Maybe you want to put that in some sort of custom code or make some really special two-string implementation that can't be expressed in the DSL. That could actually be a nice feature to be able to.
Yeah. I'm not sure I could generate that happily. If you needed that, I suppose you can create your own base subscription class. You know what I mean?
Yeah.
And some sort of decorator class. It could be done. If anyone has an idea how we can make that happen, I'm happy to hear about it.
I think that's related to the other question earlier about some sort of template system, because I think that was about, can you change how the code is generated? Or is it included in the code generator?
The way it's generated is through the code DOM, which, if you guys are familiar, is not fun, to say the least. I suppose we could change over to some sort of templating system that would allow customization, and I would be okay with that, I suppose.
Oh boy, we got a lot of questions about this stuff now. So Thanks, Philip, for kicking the bee's nest here. So let me go ahead and pull up one of these. I'm going to pull this one up because it's from your boss.
Oh, great.
So, Scott asks, so that could be virtual?
What could be virtual?
I guess that he's referring to the, would it be the I guess like the custom methods you could override, like just I'm not sure exactly. And then someone else put yes, extension methods. Those came up in the past few minutes here.
Extension methods. Well, those are easy enough to write, right? You would just create your own static class and create an extension of it. I'm not sure it could be intelligently generating extension methods.
Yep, I guess that's true. Well, no, I guess that, in terms of how I could see you using extension methods in the context of this, if you have some synthesized like base classes you do as part of using the DSL, and you had some custom stuff you wanted to be able to do. Let's say you wanted to be able to go and extend. Maybe extend one of these methods to introduce some, extend one of these base classes to introduce some custom logging or monitoring stuff, like maybe some sort of aspect-oriented thing that you could do statically through an extension method.
That would be cool. I think we'd have to move to a templating generation system for that. Yeah. As we stand now, I think it would be just as easy to create your own and kind of decorate these things. I'm all ears, though, if we can come up with a way to do that kind of stuff.
Before I go on to Daniel's question, I'm going to go ahead and pull up another one from Philip real quick. Code dumb? What? Roslyn, perhaps?
Well, I honestly, when I wrote this, I didn't want to have a bunch of string formats and a templating system, and the easiest thing to grab was the code dumb. And that's what I went with. And then generating this kind of stuff with CodeDOM, oh, that was fun. Not at all. But, when you get into a problem and you're into it, you'll sit there for 3 hours and figure it out, right? And that's what I did.
Philip, I expect to see a fork of this repository in your personal GitHub branch by the end of the day. That's a good question. All right. Next one I'm going to go ahead and pick here we'll grab this one. Oh, well, I want to get to the one from Daniel, but I'll go ahead and touch up on Bart's. I meant extension methods as an answer to your custom equality operators to strings, etc.
Okay. That makes sense.
That makes sense. Thanks, Bart. All right. Now I'll pull up this one from Daniel. So this is not about the DSL, but this iState handler is new to me. Is it some kind of actor for like a finite state machine?
No. This is simply an interface that does that. And I don't remember why I needed it, but I did, and it's there. So currently, in the current state of the DSL, you'll need to have that interface handy in your code base. That will go away.
Got it. Well, so what it looks to me like is this DSL is going to save a lot of time writing boilerplate code, but it's an early project and it's only been used internally. Sounds like there's tons of people in the virtual meetup here. There'll probably be even more in the Gitter chat later who can see possibilities for themselves with this. So I would love to see this turn into a full-fledged open source project with a community and with some evolution behind it, because this could potentially be a huge productivity boost for Akka.net users. So I think this is great. You guys did a great job.
Thanks.
All right. So go ahead and mark that. Last question here from Ibrahim Haddad. Do you have some samples we can look at?
I do. So I'll put this little sample application online, but in the actual repository of the DSL, there is a tiny little sample as well, and I believe Aaron's going to post a link to that.
Yes, it's already up on the Hangout page, and then once the meetup's done today, I'll go ahead and update the I'll go ahead and update the YouTube page and the blog post for Petabridge as well. So we'll have a smattering of links going back to it.
I also have have plans of putting out there a new demo application, somewhat similar to a real-world case usage of all this, along with some of the aggregate root, the cluster sharding and all that stuff, and that'll really show where this shines for a big project. But I have no ETA on that.
All right. That sounds good. Well, Chris, thank you very much. Go ahead and stick around in case people think up some more questions to ask you after Chris Stevens' demo he's going to do here. So, Chris, I'm going to go ahead and put you on deck here as the next presenter. All right. You're muted at the moment, by the way.
Hello. There we go.
Hi, Chris.
Hear me now?
I can hear you just fine.
Hello.
Chris, why don't you tell us a little bit about what you do?
Sorry, you broke up there.
No problem. We'll go ahead and blame Google. Tell us a little bit about what you do.
I'm a senior database engineer for cellular sales. Currently, we're working on a new system, and what came out of it is this cluster monitor that I'm going to talk about today. It's basically an example, as you can see. I got a slide presentation. We're going to go through that, and we'll get started here.
All right, that sounds good.
Alrighty, so the Akka.Cluster monitor, basically up on GitHub, I put up an example of a Windows form and a website that basically just displays current unreachable members and then also who the members are being seen by. Basically, the technology, well, here's my introduction here. And I do work for cellular sales, my personal email address, and then also the location of the Akka.Cluster tool. Everything's up there for the example for it to run. So hopefully you can just check it out and start it up and start checking it out. A little bit of background. Basically, we previously used Classic ASP, Backbone, Dapper, MVC, SQL Server, and then, of course, top shelf to run our services. What we're heading towards now is going to be using Akka.NET, AngularJS, Entity Framework with MVC, SignalR, and then, of course, SQL Server and top shelf as well. With that behind it, I'm a database engineer, and I do love working the full stack, as you can see, all the way from the database services to the UI. Like to have my fingers in each one of them. So currently, what I've been tasked with is to rewrite an existing service. So just like every company, we have data, and in one way or another, that data is linked to a region, a location, or even a person who sold you that item. So in our case, we have dealers that are going to sell you a phone or accessory. So let's say we have 20 regions with our existing product. Each one takes 3 minutes. That's an hour of runtime just to aggregate all that data. Moving forward, we really need something more real-time. So what we do need is to be fault-tolerant, so we can be up continuously. We need to be able to scale up and scale out, and also provide real-time statistics. Starting off with every actor, which brought me to this, was every actor execution is in its own context. So then you don't have to worry about locks or anything like that. First, starting before Akka, we started dabbling with threading. So creating a prototype with that, you have to manage the threads, the objects, whether or not something is locked. And then I just want to leave that behind me. That's a decade ago. We shouldn't need to worry about that. So then I started looking at tasks, and which is great. Manages the threads for you. Don't have to even think about that really. But you still have to think about your shared objects and having those locked so you don't have any conditions or anything like that. Let me see. Oh, lost my place.
So hey, Chris, let me just ask you a couple questions real quick. Actually, so you got a little bit of feedback coming here, so I'm going to mute you for just a sec. All right, there we go. So my question for you is, in terms of your processing and everything that you're doing here, in terms of the business case? Sounds like you need to go and aggregate a whole bunch of data and send some reports back. What's the need for making it real time? So what's sort of driving that? So I think you muted yourself, so you should be able to unmute here.
I did. Okay.
There you go.
Yeah, basically the drive is just to make sure that we have real time what's going out the door, or who's selling what product and who's on top of the board. So we just want to make sure that those people are recognized and are able to get the latest and greatest statistics, basically, to do their job.
Got it.
Yeah, was that?
Yep, perfectly answers my question.
Okay, cool. Yeah, so basically after stepping all through that, I was talking to my manager, telling him basically the issues we had, or that I was having, trying to get all these processes to communicate with each other and kind of not stepping over each other. So talking to him, he's like, you should go check out the actor model, which then led me to the web crawler project, and pulled that down, started playing with that, and that I felt like that's very similar to what we kind of wanted to achieve. But again, I mean, this is all new, and that's months ago, so had to start digging through all the bootcamp examples that you guys provided, which are awesome to keep me going, and then also just ripped the web crawler project apart. So basically, that gave us everything we need. Actors are async and lockless. Got a step ahead. So basically, to do fault tolerance, the supervisor strategy gives us that. Location transparency allows us to scale up and even scale out. And then also I can send a message from anywhere. So I can send a message from my service up to my web, and then down to the Angular project. So basically what I have done is I started off with, I have 3 different ways to monitor my cluster. The first way that I developed was the Windows format, and basically, let me switch screens here. So during the development, I would have issues where my members would just become disassociated. I had no way to know why or anything like that besides looking at the log. And then also, how do I get that member to get back in my cluster? Did it leave? Does it need to be reincarnated or whatnot? And some of that, I had to go stop the service, start it back up, and sometimes even just bring the whole cluster down and then bring everything back up just to get it working again. I just felt like it's something I shouldn't need to be doing, and I needed a way to monitor it. So I actually started experimenting with the auto down reachable after setting, and that really made my cluster, I don't know, as Roger would say, become split brain. So started digging into it and found that you can actually hook into the events with the cluster event. So what this does is allows you to get the current cluster members, what members are unreachable, and then who they're seen by. So basically, it's set that up to subscribe. Jump over here some code. So basically, when you start up in your actor, you're just going to do a cluster.subscribe, and then you can subscribe to any of the cluster events, and then that will give you the messages based on any of those. You can get events such as the cluster state, whether the member is up, unreachable, or even has been removed. Basically, this didn't go too well because of our network. So basically, I'm on my laptop trying to connect to another network system, another network segment, And when those members on that other network would basically see my app as unreachable, and that really kind of got everything, I don't know, out of whack. So to get it to get my monitor away from being the Windows Form app, I went ahead and looked into how do I move my monitor closer to my cluster, basically. So then I came up with the cluster web version. It gives you the exact same info as the Windows Forms. And then trying to keep up. So basically, it gives us everything that we need. It allows me to tell one of my members to just leave the cluster, or if it's become unreachable, I can just go ahead and down that member, so it's not part of that cluster. And so the cluster can continue working because if one member is disassociated or is in a leaving state or any of those states besides up, you can't have another member join. So everything's kind of got to have talked together to have that member join. The nice thing about moving it to the web base, though, was that gave me the opportunity to use SignalR. So now I can just pump the messages directly from the cluster status to the web page. Just love it. It's just magic. I can show you a little demo here shortly. Let's see here. Actually, I'm going to take a back step, and we'll go ahead and launch up the Windows Form.
Sure, go for it.
So this is the initial state of your of the Windows Form. Of course, you're not going to see anything because we don't have any other services running. So we'll go over here and start up the Lighthouse, and we'll just go ahead and start up 2. And you can see the members starting to join and whatnot. So this is the Windows Form app. And from here, you can go ahead and just click on the Lighthouse. You can go ahead and hit down, and it'll go through the down process. And you can actually see over here on my services, it's stopping, and now it's shut down. So that's kind of a sweet taste. If anything becomes unreachable, it'll show up here, and then it'll also show you the seen by members. Just a little tab here, you can actually see just a log of those events being captured, so you can see what's happening with that member. Now to the web version, I'll close that out, and we'll just stop everything. Okay, so now what we have is that we'll go and start the website up.
So, in case you've never used Akka.Cluster before, what he just did is the equivalent of magic, essentially. He being able to, so he's subscribing to, so inside, the way clustering works is there's a bunch of events that get broadcast and shared between each node in the cluster that tell you, like, here's a new node that I found, here's the last time I saw it, and here's what the status of it is. He was able to go and use those events to do things like tell the Windows service that Lighthouse runs on top of to shut down if it gets removed from the cluster. So that's pretty amazing. And he's just using the cluster actor system extension that gets exposed by Akka.Cluster to go and get access to those messages. So that was the little code snippet he showed earlier. So just wanted to call attention to that for anyone who's not played with clustering itself yet.
Yep. And so also with that event, so how I'm able to, when I tell one of my members to leave, I have this cluster status actor attached to all my services, basically. And so when it gets notification that the member has been removed, it'll just check to see, is it myself that's being removed? And if so, it'll go ahead and just go and call this method, report that it is being removed, and then goes to this state of calling the host stop, the host control stop, so that the service stops. So that's all fine and dandy, right? So we're able to have our website boot up. I'll even start up another one. And so both my websites now are part of the cluster. Now, there are certain cases that I've read that, just put an endpoint on that, and that kind of got me intrigued. So basically, what you can do is do a web API endpoint. And so using Top Shelf, rather, makes this very easy. So basically, I lost my bookmarks. Here we go. So basically, to wrap up an endpoint, all you do is throw this within your Top Shelf, call it the web endpoint, and now you have a way to access your Akka member through the web API endpoint, which I have a demo here as well. So basically, you have the same screen here, except instead of having it having this website member part of the cluster, I can actually just do it via JavaScript, make a call to this endpoint, and get the same status back. Oh, well, if it was started. So that kind of leads me into the next phase. So that's go fine and dandy. I can go ahead and come in here and say, I want my lighthouse to stop. But what if I want to come back up? Well, I have this service status. And so this allows me to monitor that website and the services on there. And so right now on my box, I have Lighthouse running. And so let's go ahead and start up another Lighthouse. And you can watch it come over here, start to join. And we also, what I was going to demo was the worker with the web API. So let's go and start that service up. Now that that's joined, now I can go ahead and call the API. So let's go and call that. And now this page has nothing to do with Akka or anything. It's just an endpoint pulling back the exact same object model as the other one. Granted, my leave buttons and down buttons on the API are not wired up yet, so those don't function. Not implemented yet. Soon to be, hopefully. But, I mean, just like you could do with the Akka scheduler, just repeat and just constantly get a feedback. So here, I can go ahead and tell my Lighthouse to leave. He's leaving, exiting. Over here, he's exiting as well. And then you can also see that he's in stop pending, and will eventually stop. You'll also know that you'll notice that my cluster leader was the main lighthouse. So once I stopped it, it did switch the cluster leader to the other lighthouse. If you do notice now, once I do start my other lighthouse and it does come up, it should take over as the primary leader again.
So
go ahead.
I would say, so that is absolutely amazing.
Thank you. A lot of work. Mm-hmm. So yeah, so that opens the door. Several different ways you can monitor a cluster. You can tell it to leave. You can tell it to down. So basically, if a service gets in an unreachable state and you're trying to bring up another member into it, you're not allowed to. So basically, you come in here, click on the down, that member would leave, and now you're able to successfully bring that member back in. Let's see here. So basically, I skipped ahead of my slides. Back there. So real quick on SingleR, while I'm touching that. SingleR is awesome. It allows us to pump data from multiple web servers to a single client, or basically you can either broadcast that message to all your clients or to a specific client that's subscribed to it. In my case, I'm just going to broadcast all the messages. But the issue that I ran into is if you're behind a load balancer like an F5, you kind of get weird things going on. And so using the backplane within SignalR, you'll notice that I'm running 2 websites. And you can see here's both my websites, but I'm only on port 88. If you go to my other website, port 89, you can it'll tell you the exact same thing for my cluster status. It'll list both web servers, and so it kind of gives me an idea of the status of the state. So they should be identical right now. If you become split brain and you get multiple clusters, you can actually witness it. Like the left side would have, 1 lighthouse and a couple workers, and then the right side would have the other lighthouse and a couple of the other workers. So you can actually feel for what's kind of going on with your clusters. This kind of led me into the main thing that we were working on. I can give you a quick demo of that, and that's the item status. Item status is pretty cool. This is what gives you the real-time kind of look and feel. So these are my job workers. So there's nothing running right now. Well, that's an easy fix. I don't have to log into anything. I can just come right here. I can start up a worker, start up my other worker, and then let's go and start my tasker. And so once my tasker starts running, make sure everything is up, it joined, and now over here, hopefully, yep, there it goes. So now it picked up and just starts pumping out the messages. Here's my status. I have these jobs being tasked out to the job tasker, and then the job tasker is going to find one of the workers to do the work on. And then it just reports back. And so here's the items that it discovered, the items processed. You can actually slowly see these guys climbing up as it's working to its way to be finished. Other than that, I think.
So,
go ahead.
For the tasker to work, is there a specific API that your project exposes that someone needs in order to signal like a task that's running? Like, would you show us the source for that?
Well, you can actually see the source, Aaron, by looking at that web crawler.
Oh, okay, I see.
Yeah, so basically, yeah, that's where I kind of got the idea from. So, yeah, the code here for the tasker is very, very similar to the web crawler, literally. So thank you guys for setting that up and getting us all going on an awesome example.
You're welcome.
So, yeah, so I stole your code and just munched it all up to be mine. So, yeah, you have the start job, basically. So what this guy here is doing is that I have an actor that is a tasker. He goes out on a delay, and he just sits there and pumps, every 15 seconds. He goes out, finds some work to do, and then tells the job master, go ahead and start this job, just like the web crawler does. And then he goes out and did a little bit differently. Instead of like retrying to find one or whatnot, I created a job coordinator. And basically this job coordinator, the only thing it is responsible for is to create a worker. So it goes out, creates the worker, returns the reference, and then go ahead and put that job over there on the worker, and then the worker reports back.
All right. Got it.
And that's it. Questions?
All right, we've got 2 from Philip Loriano. So I'm going to pull up the first one from him that has 6 votes. Has this been tested in a cloud environment such as Azure or Amazon Web Services?
No. This is all actually in dev. Hopefully be moving to production here in the next few months.
And is that going to be within your own data center or on a cloud?
Yes, it'll be in our own data center.
Okay, got it. So no, not yet, Philip. You can be the first.
There you go.
You can be a pioneer. All right. Well, I will personally be giving this a try on Azure in the near future here. All right. Another question from Philip. Does this mean that I can see the cluster status by connecting directly to any one of the cluster nodes via a web browser? If that's true, then this is definitely a game changer.
Well, I mean, you can based on if you do it the web API way, and you would actually have to have, like I showed you earlier, you'd have to set that call up on there. So if you're using top shelf, where'd it go? Programs. So here on my web, the service called Worker with Web API, I introduced this little piece of code here, and that basically allows me to create an endpoint. So I do that, and then I have an API. Not that one. I have this cluster status controller. And so in here, it just has an endpoint of just get me the cluster status. And the ID was just something to play with. But so yeah, so basically that just goes, gets it, and returns me the state. That's it. So I don't have to be part of the cluster at all to get that cluster information.
So what you could do is you can go ahead and just package up that cluster status controller into a NuGet package and just have that installed in all your top shelf services, and then it would give you that, right, Philip? Or sorry, right, Chris?
Yes, you could do that.
Yeah. So that's something that you guys could do possibly in terms of being able to make it so any node can give you a report back on what's up and what's not.
Right, and then you could also tie in your leave and downs or anything like that, so that you can tell it to leave or down or whatever else you need to do.
All right, and let's see. Next question from Bart de Boer. How generic and reusable is this for any cluster with n number of roles?
Right now, since we only work with one really role, I don't have any that has multiple roles, so you'll notice that I just use one. Really, it's all driven off of the cluster event, so that's all the same. So it should work anywhere as long as you can connect to it, to that cluster.
Okay, I'm just posting a GitHub link there's already links to, by the way, the DSL and the monitor NuGet or GitHub projects on the Petabridge blog post announcing the meetup. But I also went and pasted a link directly just now on the Meetup event or Hangout event page just now. Let's see. Chris Martin asked a question here inside the speakers chamber that I want to go ahead and pull up. Any plans to work on deploying new nodes? So I guess that'd be the equivalent of like deploying a new, just to make sure I understand you correctly, Chris, deploying like a brand new virtual machine.
No, not a whole machine, but if a machine were up in your data center, it'd be great to be able to say, hey, deploy this actor system to that node. Kind of like I asked last night if it was similar to DataStax's Ops Center for Cassandra.
Mm-hmm.
I don't know if you're familiar enough with that, but you can say, hey, here's an IP address in my data center. Go ahead and deploy a Cassandra node to it.
Oh yeah, I'm real familiar with it. Well, I guess what it would need to do was you need to be able to like bin deploy a like a top shelf exe and start it, right? You need to go and basically like start a process.
Yes.
You know, if you had something like an open, I'm gonna let Chris answer, so I don't monopolize the time here. But I guess if you just had something installed on each virtual machine that was able to like handle a bin deployment and start a process, then you can make that possible.
Right. I was looking at maybe an auto deploy MSI that you can silently install.
Yeah, that could work too.
That would be cool.
Maybe we can just do what all the cool kids do and just Docker everything, right?
Well, that would be cool. But
yep. Chris, what's your thought on that?
Yeah, that would be kind of cool to just deploy it.
All right, got it. Another question from Philip here. Cluster inception equals having another actor system watch nodes for up-down state and then downing them through remote API calls. So theoretically, with Chris's web API, where every single cluster node is connected to this REST API, you could do that. You could remotely down a node. You could basically remotely down a node by making an HTTP call from inside a totally separate Akka.NET system that's not connected to the original cluster to go and down it or something like that. So there's what Chris has opened up here is a lot of different possibilities for being able to remotely, not just like, I think honestly, man, you're kind of cheating yourself a little bit by calling this a monitoring tool. This is a management tool.
Well, it started off with a monitoring, yeah.
Yeah. But I think there's there's a tremendous potential in this project. So I think that that's something that could really be a real game changer for people trying to use the high availability tools in production. And at some point down the road, one of the modules we're going to get done as part of the cluster release is cluster metrics, which will allow you to subscribe to things like the amount of CPU utilization per node and memory utilization. And then when cluster sharding starts getting more pickup, you'll be able to start reporting things like how the shards are balanced across the cluster and stuff like that, at which point it basically will become DataStax Ops Center, essentially.
For sure.
But yeah, there's a lot of possibility with this. I think this is a great project.
And basically, when you pull it down, I hope anyway, if you just run everything, it should just magically work. So I provided 2 lighthouses, 2 websites, the WinForms, 2 workers, and then a worker with a web API to give you the full-blown demo.
And then the last comment here, again from Philip, for doing our remote deployment would be Octopus deploy. We're considering that. So, yeah, I think that'd
be for our deployments.
Yeah, very cool. I think that's awesome. And then last question, cluster.matrix. It's a cluster.metrics. Sorry, I mispronounced that. Cluster.matrix would involve a bunch of fully sentient computers trying to kill all humans. So we might have a problem there if we invented that. But yes, cluster.metrics will be coming out as part of the clustering sort of stable release. All right, next question. In a real-life scenario, what would be the reason for having so many different cluster members? Chris, or actually, Chris or Chris, either one of you want to answer this?
Yeah, either way. Well, to start off, since I'm at the top here, you definitely need 2 lighthouses if you're going production. That way, if one dies, you can actually get that lighthouse or that main node back in. So definitely have 2 of those. If not, you will become split. Other than that, right now I only have 1 tasker. The web crawler has 2 taskers. That way, they can talk to each other. But basically, really, it's for scaling out. So in my case, I have my tasker, and as you can see over here on my workers, I have a tasker that's going to task a job. And as you can see, I don't have them all running. Oh yeah, right here. So this is on a port, and this is on another node. So right now, I'm able to process 2 jobs, 1 on each server. That way, if it's heavy-duty aggregation of data, and it starts to bogging down, I can just bring up another service and handle that load. So during the holidays, just bring up an extra 2-3 servers, and we should be okay, right?
Yeah, absolutely.
Does that answer the question?
I think so. Actually, I'll turn the microphone over to Chris Martin too, if he wants to take another stab at that.
No, I think you nailed it. It's scalability.
Yep. All right. Good. So last question here. We use Octopus Deploy plus Amazon Web Services groups to detect high CPU usage and spin up 4 VMs at once. Yeah, we used similar things for that at my previous company. We used Elastic Beanstalk and auto scaling there, but that was prior to Akka.Cluster though. We had to do everything with Akka.Remote. This is like early 2014. We were doing all that stuff. Okay, got a question from Sean Gilliam. All right. Since this looks like a cluster management tool, how is this secured? Ooh, that's a great question. I know in the JVM, Akka uses JMX. That's the Java Management Experience. Really awesome project, by the way. So yeah, Chris, how would you secure your cluster management?
Well, yeah, I mean, that's the other thing is there's no security. So if you really want to secure it, then, do the web API and put some security around that. Other than that, I mean, really, since there is no really security around Akka yet, really, you just go right here and you just say, I want to connect to this service, and you give it the IP address, and as long as you know it, you'll be able to connect to it. So security is not very secure unless you're within the network. So that's why kind of led me off going to do the website version as well, because then I can put that web behind the firewall or anything like that. I don't have to worry about anyone trying to get to it.
Yeah, just to tack on to that, so one of the things we're going to be trying to add to Akka.remote is TLS pretty soon. That's one of the things we're going to get when we switch to the .NET transport, since it already has TLS support baked into it. But the sort of bigger question of how do you secure an Akka.NET cluster? Right now, the best practice that I use this in my own production deployments, and I know others have too, is to make sure that your Akka.cluster exists within a private zone. So that'd be like a virtual private cloud on Azure, AWS, and I think all clouds by default, if you go and create a brand new account or service, are all private there. And within your own data center, that's fairly easy to do, like within a private network zone, right?
Yep.
Yeah.
Yeah, in Azure, you would just create a new VNet, right? And your public API would be the one secured.
Yeah, exactly. So you might have a public API that gets exposed, or a public website that gets exposed that's open to traffic from the open internet, but all the stuff in your Akka.NET cluster sort of sits behind that in a totally closed, sealed, hermetically sealed part of the network. And that's the best practice for the time being. So at some point down the road, maybe if you guys start sending Chris some pull requests, you can implement something like integrated security or something like that. So
cool. Oh, maybe some UI love too.
Need some UI love too. Hey, I think the default boot. This is a perfectly functional website. We don't need to we don't need to guss it up with any nice fade animations or anything else.
It's animated enough.
Yep. Let's see. Next question from Bart. Sorry, but what I meant was different types of executables in your project. So like web and I can imagine web and service in different roles, but that could be the same exe/set of DLLs. So he's talking about what's the need for having different executables within a cluster. So like heterogeneous software in a cluster.
Just to separate, I guess. I mean, you could run everything within the one service, but then you're kind of, what if that goes down? You have to bring another one up. I mean, you could.
In practice, what I found is that the primary reason why you go and break up members of a cluster into different roles with different like code bases is typically services have different scalability requirements. So a stateful service that keeps track of a bunch of data and it's always up to date doesn't do very much work, and you don't really need very many of them. They don't get upgraded very often because doing an update to a stateful service is a much more complicated task than replacing a stateless one. And your stateless services, so like in the case of Chris's example, if he needs to go and aggregate a bunch of data and do some reporting and then move on to the next job, that's something you can automatically scale pretty easily because the service starts from scratch every single time you boot it up. You don't need to worry about it recovering state and trying to get back into the same shape that it was before you disabled it. So that's one of the motivations for doing heterogeneous clusters. Then the other is just from just a pure developer experience standpoint, you don't want to have this giant monolithic service that does everything necessarily, right? If you've got a big company and you've got lots of different software teams working in concert together, maybe what you guys might want to agree on is a small set of standard sort of like public message contracts between services, and then let each of them sort of write the way that those message contracts are fulfilled on their own. So there's a number of different reasons why you might want to break things up. But those are two off the top of my head that I've put into practice myself. Chris or Roger, or Chris too. Any of you guys have any other thoughts on that?
I guess if you're running on-premise servers, it might be that you have some machines connected to the cluster might have some capabilities. Let's say you have two machines that have graphic cards that can hardware render stuff if you're doing graphical stuff in the cluster, and you could deploy that code on only those machines. Still, you could, of course, still have that monolithic deployment, but I guess from a separation of concerns perspective, I at least would separate those so I have different services for each individual role.
Yeah, I agree with that. You might have unique, some services might have unique dependencies, right, that are specific to the hardware they're running on. That makes sense. Any other thoughts?
No, I agree with Roger.
I haven't really split anything up into roles yet. I definitely can see some use cases for it, but I, as yet, have not.
All right, got it. Okay, next question. I'll take this one. Did I just hear that we're moving to .NETty? Will Helios be deprecated? Yes and yes. So Helios has served us very well over the past 2 years as the sort of faithful little socket server, but it has some problems. Namely, it was written in a bit of a hurry. Just being totally transparent, they're written in a bit of a hurry, and it's a little brittle at times. And its performance has also come into question lately. So one of the things that I had started working on this summer was Helios 2, which was going to be a big rewrite of Helios to try to get it to more closely match the NETty project. So Helios is ported from NETty, which is a really well-known, powerful socket server in Java. NETty powers the internals of Apache Cassandra and lots of other big data projects like that. Well, it turned out some folks from Microsoft had already been working on that, and their project was called .NETty, and so I decided to go ahead and direct any of the work I was going to do on Helios 2 to work with them instead. Better to have some convergence around something that's that essential to the .NET ecosystem than to have two sort of split projects, in my opinion. So we're going to be we already have a .NETty transport written for Akka.net, and one of the things I'll get into after we sort of wrap up the QA on Chris Stevens' demo here is I'll get into some of the things that we're thinking about doing in order to try to take Akka.Cluster out of beta, and this directly relates to that. So hopefully I answered your question sufficiently for the time being. All right, next question from Bart. And how does that work for the web API roles that need on the HTTP front end to be exposed? Do you rely on the firewall in front of it? So I guess Bart's question is, I'm assuming he's referring to web API roles in general, not specifically the cluster monitoring web API.
Yeah, within our app, I mean, we use Active Directory, so that monitoring page that I created within our app is you have to log in with your AD credentials to even get to it. So that's part of the permissions issue, or part of the permissions resolution there. Yeah, other than that, we don't have anything external facing or anything like that for what we're doing. It's all really internal. So that we haven't really touched on.
Well, I've done this in production before. So this was with just Akka.remote only. What I did basically, I can go ahead and post a link to this on my. Actually, let me grab it real quick. I've got a network diagram that showed how we did this. But basically, what we did was our web servers were still public on port 80, and we had like a big REST API that was collected. People were doing thousands of requests per second against it, and that web API kept a connection to a Windows service that I wrote using Akka.remote, where it would go and basically pull any of the messages that were interesting for that service and then forward them along via Akka.remote like that. So the web server was public facing on port 80 and on our SSL port too, 443. But all the ports for communicating with Akka.remote, so we used like a bunch of ports in the 4 and 5,000 range, those were all private, and only services within our private cloud on Amazon could listen for any communication there. So you sort of have this private/public strategy where you have a couple of whitelisted ports that are available publicly through your load balancer that people can go and access your web service on, and then all of the socket communications that happens within your Akka network is all done within a private zone. So that way no one could open up a socket connection or their own Akka.remote connection directly to any of my boxes and start sending me bad data or something like that. So that's generally how you'd secure something like that, is sort of have a private/public policy. All right. And the last question here on the cluster monitoring demo would be a follow-up idea. It'd be interesting to see specific monitoring and metrics for all roles, like are all roles present, etc. So I guess that'd be like some sort of historionic view of the cluster. Like if you've observed these 5 roles over time, be able to go and report, we don't know about any nodes in this role. Right, Chris?
Yeah, that'd be nice to know if you can detect that stuff.
Yeah. I guess you'd have to have some sort of durable store that you'd write data to, like a database or something, in order to do that, right?
Yeah, that's why I stopped. I had to think through all.
Yeah, you could do it. Yeah, I could see a lot of value in that. It'd also be useful for things like if you wanted to add alerting at some point in the future that a node was down, maybe you'd have some sort of a historical data on like, here's when this node went down, and then here's when it came back, that sort of stuff. So, yeah, that's a good question. Okay, well, thanks. So first, Chris Martin and Chris Stevens, both of your demos were awesome, and what I'm really blown away with is just how you guys have gone on your totally without any communication with the core Akka.net engineers and built these amazing projects on your own. That shows really like amazing sort of growth of our community overall. The fact that you guys and your companies both allowed you to put forth those efforts. So thank you for doing that and for really being champions or help building up our ecosystem more and more.
Yeah, thank you for getting that going, really. It's awesome. I mean, I love the scale out and location transparency and everything, so hands to you guys for keep working on it too.
Yeah, it's awesome. Every time I come back, I got UI work to do, and I come back to the server and I see you guys release new stuff, and it's awesome to work with.
Oh, great, thank you. We have a really strong community around the project, and it really is a group effort to do all this stuff. So it's just great to see this. My goal is we're gonna try to do one of these every month, and I'm gonna try to get some folks in here from the Even framework, and maybe and to see if we can give them to do a presentation. So without any further ado, if you need to hop off at this point and go back to work so your boss doesn't yell at you or something like that, you can feel free to leave now, but I'm going to stick around, and I think Roger is too, for a few minutes and ask some, and basically get any general questions you all might have. So we'll start with this first one, since it's directly relevant. What's the GitHub link for Akka.Cluster.monitor? I just dropped a link on the page, but I'll go ahead and drop another one in Gitter chat. So I just dropped a link to it there, so if you want to go ahead and get that, you can do it.
Hey, Aaron?
Yes?
Yeah, you just said earlier, big thanks to the company that I do work for, Cellular Sales. It does rock, and hands off to my management for allowing me to do this for sure. So I do appreciate them doing it, and hopefully I'm going to do this talk for CodeStock. At least I'm going to submit that for our local talk. So yeah, I just want to give that shout out. So I appreciate it.
Well, it's a really good thing in the .NET ecosystem overall. Just to get on my soapbox for a second here, and Roger, you can. Yeah, I think you and I have similar opinions on this, which is that the .NET ecosystem for a long time kind of existed in this I think of it like an Amish community in the United States, where they sort of are isolated from all the other innovation that's been happening in open source, and that's the way it was for maybe 10 years. Really, in the past 4 or 5, it's sort of turned into be looking a lot more like the vibrant open source communities around technologies like Java and Ruby on Rails and that sort of thing. And the thing that's made that possible is companies like EventDay and Cellular Sales, who recognize the benefit in participating in these open source communities. And it's not just about taking stuff in, but it's also about putting ideas and feedback and projects back out too. So really a big shout out to both your companies. And I know if you've got coworkers or bosses who are on the call right now, definitely a big shout. You guys are working for great companies that are really helping make .NET a better place for everybody.
Cool.
Thanks.
Thank you.
Yeah, anytime. All right. Next question from Sonic Flare. Oh boy. Any updates on Akka.HTTP? Well, Roger, I'm going to throw you under the bus on this one.
Yeah, we have discussed it a bit, but I guess it makes a little bit more sense on the JVM, where there wasn't really that much HTTP frameworks that were easy to use, but on the .NET side of things, we do have nice HTTP frameworks that works nicely async also. So I don't know how much return on investment we would get if we actually try to port Akka HTTP, because it's really easy to just wrap an actor system up in NancyFX or Web API or something like that, and it's async and everything out of the box. So maybe we do it.
What we've talked about doing, I guess, kind of a good time to bring it up. It would be something a little similar almost to what what the sort of the output from Chris Martin's DSL thing would be. Would essentially synthesize like a Nancy web application that provides controllers and routes back to your actors, and would just piggyback off all the work those guys have done, rather than implement our own HTTP server, which I think there isn't a lot of excitement or enthusiasm for, understandably, within the Akka.NET project to do that. So we might do. So we've talked about doing a compromise like that before, which I think would be much more feasible, right, Roger?
Yeah, absolutely. And I've seen some users have opinions on API for Akka HTTP on the JVM, that it's not really that easy to work with routing and things like that. And since it's solved really nicely in the frameworks we already have on the .NET side of things, I think it would be strange to introduce yet another abstraction that is not quite as good as what we already have. So,
yeah, I agree with that. So, are there any other general questions that our meetup attendees want to ask? We got a little bit more time here, but otherwise, we'll. I guess I have one thing I'll talk a little bit about if there aren't any questions, which is a question I want to put forth to the Akka.NET community in general. So the big thing that we've been chipping away at for a while is trying to finally get a stable version of Akka.Cluster out there. Akka.Cluster in general works pretty well. You heard Joshua Benjamin talk at our last virtual meetup about how his company has been using Akka.Cluster in production for like a year. So the module itself is in respectable shape, but we have a really high quality standard before we take the beta label off. One of the things we need to do as part of shipping that is we want to replace Helios for the reasons that we described earlier, and replace it with .NET. We've done a lot of the integration work with .NET already. We know that I've been able to run the multi-node test suite with all passing marks on it. We know that the performance of .NET is a lot better. We know that we get TLS support and a bunch of other good stuff out of the box. So it'll really put us in good shape. One of the things we need to make a decision, though, is that right now Helios and .NET aren't wire compatible because of a issue with the way Helios is designed. We can roll out Akka.Cluster a little bit faster if we go ahead and just rip the Band-Aid off and pull .NET in right away. But the disadvantage of that is that anybody who's running a cluster that uses Helios right now would have to take their service down during the upgrade. And so then we have customers who are, well, not customers. We have users who run banks and, healthcare systems. So so that might be a real issue for them. So one of the things that we're looking for some feedback on is whether or not you'd be okay with us doing that, or maybe we need to add on like another 3 to 4 weeks to go and do another patch to fix Helios so the two can be wire compatible, which is what I've been planning on doing by default anyway. But for people who really want to be able to use Akka.Cluster at work, and the one thing that they can't sell to management is the fact that we still have it as a pre-release NuGet package, this is a bargain that we can sort of put out there to maybe get it done faster. So our current approach, and sticking with our sort of semantic versioning methodology here, is that because we're treating this as an Akka.NET 1.1 release, it's a feature release. We're not going to make any breaking changes, so we're going to make everything backwards compatible, but that does add on a whole bunch of extra time because replacing the network library has been a big chore. So if you have any thoughts on that, please go ahead and let us know in Gitter chat, or let us know here in the questions area, and yeah, we're really curious to hear what you think about it. So I got a couple of feedback points on the web API, or I guess the Akka.HTTP question earlier. So let me pull this up. A web API bridge to an Akka.NET actor system would be nice. Having HTTP endpoints and make it easy to talk to actor systems. Yes, absolutely. The primary use case for Akka.HTTP, as I see it, is if you have something like a mobile client, like a Xamarin app, that needs to be able to go and talk to an actor system. It's probably a lot easier just to make an HTTP call than it is to use Akka.io and open up the socket, which also works, or to try to do something else. So there's a lot of really good reasons for Akka.HTTP to be a thing. And then one more comment on that. It's easy to wrap web API, and we are using it. It's just how future-proof this is in regard with Akka.HTTP. Roger, you tell me, but I think the way we structure hierarchies and actor paths and actor addresses is, if I had to pick a list of 5 things that are really unlikely to change in the next 5 to 10 years with Akka and Akka.NET, the addressing system is one of them. Yeah, would you agree with that, Roger?
Yeah, absolutely.
Yeah. So if all the web API does is basically just extends that that addressing system to be also exposed via HTTP, then it's likely that all the people who are making calls to that HTTP system, as long as you don't go and change your actor hierarchy, which is totally within your control, any future release of Akka.NET's not going to affect that. So, yeah, so that's hopefully that answers your question. Okay. Any other questions? Nope. All right. Well, in that case, we will go ahead and end the meetup here. So this will be recorded and published back into Petabridge's YouTube channel. So if you missed it, or if you have a friend you wanted to share this with, they'll be able to go and get it. Once again, big hats off to Chris Martin and Chris Stevens for their great demos today. We dropped links to all of their open source projects in the Petabridge blog post and in the Google Hangout. So please go and check those out. I'm sure both of them would welcome your pull requests with wide open arms. And yeah, let's go out there and keep shipping some reactive applications.
Thanks, guys.
Thank you.
All right. Thank you, everybody.